Well, hi everyone. My name is Françoise, and I'm a data analyst at Shopify, and I also am one of the organizers of GDG Montréal. And recently at Kung Fu, I gave a talk with the exact same title and the exact same talk description, but this won't be the exact same talk, because for this audience, I really wanted to tell my story from a much more personal perspective, basically for two reasons. One of the reasons is that I went through a transition in careers, and learning about and hearing about other people's journey through that sort of thing, like what we heard this morning, was really inspiring to me. So I want to give back to this sort of audience by sharing my story. And the other reason is that now I'm like in the business intelligence analyst world, and I did not study that at school. So like if there are people in the room that actually have a business background and you're wondering like, why isn't she like using these KPIs that everyone uses, or why isn't she using the tools that I use? Well, you will know that I'm coming from a different background, and I'm a physicist. I have a PhD in experimental physics. I was basically shooting big lasers on small molecules. In a more scientific way of saying this is I was using ultrafast spectroscopy to measure, well, to understand charge separation at heterojunction in organic materials. And what does that mean is that these things are the solar cells of the future. Instead of using silicon, we can use polymers that we dissolve with a solvent, and then we can print. It's like printed electronic. It will be super cheap. It's just not super efficient at this time. So I was working during my PhD to understand like what's really going on in an organic solar cell. And here I will simplify it for you. How do organic solar cells work? 3 easy steps. First step, light goes in. Step 2, electricity. Like, really? It's super hard to know what's exactly going on from when we go from a photon to the actual electrons moving around. And I spent a lot of time on those 3 question marks there. I've spent like 6 years in research, like 2 years master's, 4 years PhD, and there are still people working on this, and they are making a better world with those kind of scientific discovery. And like the way I think about the world that was really influenced by all that time in academia and in physics in particular is like using the scientific method for everything. And so it always starts with like, you have an observation about the world, and then you're asking a question about the world, and then you can make a hypothesis, like why. Like, if I change this, I think it will have an impact. And then that prediction, like, what do you think the impact will be? And then you actually do the experiment. In the kind of physics I was doing, it was super hard because you had to go at like low temperature, and you had to like very powerful lasers that were like, costing millions of dollars. It's like super hard to do. And then when you have the results, you analyze the results, and you reject the hypothesis, and you go back to square one, and you cycle through these things, and you continue to always update your view of the world until you find something that's super interesting, and then you update, humanity's knowledge, and then you start from the beginning. You find another observation and question, and it's always a cycle, and you can always like go back. Like it's not just a very linear way of thinking. You always update what you think. And to sum up my PhD, I was working to solve a relevant problem that helps people. That was something that, you don't do a PhD for money, for fame. You do it because like you really want to do it. You do it because you think you will make the world better. You do it because, all those hours that you put in there will make a difference. And I was doing it because it was for solar energy, cheap solar energy that we could put in the hands of like 7 billion people eventually. And also it was really fun because I was using cutting edge technology. Like in our lab we had those cameras that are not on the market yet. Like we were you know, trying, like we had the best bragg filters in the world that are made by a startup in Montreal, and we were like, you know, using duct tape to put like two very expensive machines together because like the adapters between the two doesn't exist. We had like to do everything, to build things from our hands. Like I had to like design mechanical pieces, which like I've never done before, just because like we need this for the experiment to work, and you cannot just buy it on Amazon. You have to build it yourself. So this was a really exciting time. And then came the transition year. After my PhD, well, towards the end of my PhD, I was a bit freaking out about like, what am I going to do with the rest of my life? Because I can continue in physics and become a physics professor, and that would be awesome to have my own lab with my own research agenda, but like the world is so large, and there's this new thing called like machine learning and like big data, and they're paying people very well in San Francisco for these things, and it sounds really fun, but like I don't know how to get there. And so I started thinking about my career change, and I gave myself a full year to think about this and like try a project, see if I like it, because like up to that point I've been in school basically all my life. Like I was like 30 years old, and I spent like already like 10 years old in the university, right? So like going to work for a company, like those places where there are like code monkeys, like in like a big space with like cubicles, and like I had no like good idea of what it looks like to work in a company. So I said, well, let's try it a little bit and maybe stay 1 foot in academia. So yeah, so I want to share with you 3 things that I think were very key for me for this successful year of transitioning from physics to machine learning, natural language processing, big data, and all of that. One of the very key things was connecting with the community. I decided to work with Python because I'm a scientist. Python is like super big in the science world, but also super big in data science. I know I can do music with Python. I know I can do web development with Python. So it seemed like, you know, a very safe bet. Like if I learn this technology, it gives me opportunities. And so I started attending Montreal Python, which is a local group here, and also PyLadies Montreal. And by meeting people and figuring out like, hey, how do you use Python in your work? What do you like about your work? How is it to work in a startup? How is it to work at that big bank where you're working? How is it like just networking with the community and like trying to figure out how people work and what people like and what's exciting at this point was really key. And also, PyLadies was super supportive, and I really liked that group. And I just like went to many meetups, and at some point I started organizing meetups, and now I'm an organizer there. And one of the cool things about organizing meetups is that you get to meet all those wonderful people, both people looking for jobs, people that want to offer jobs. So that's basically how I got my job where I'm working at now. We needed sponsors for PyLadies, and at some point they were like, hey, you did machine learning, natural language processing, you know Python? Come work with us. So it's a good way to build your network and get your next job. Another thing that was really key is, as you know, I had just learned about physics in school. I also did some, actually Python, but it was always in a scientific setting. So yeah, I needed to ramp up in my spare time. So I spent a lot of time on Coursera, but nowadays there are like also other sources of Masson online course that you can take for free. On Coursera there was a very good one for machine learning by Andrew Ng, sorry. Hope he's not watching this now. Because it's really an amazing class for learning machine learning. And Kaggle is a data science competition site. And it was really great to have those data sets available, because like with my job, I could not just take the data home because I had signed like agreements and like this data belongs to the company, so like, what can I use to like ramp up my skills in my spare time? Like if I want to try an algorithm on classifying images, I need to have a data set of images that's already labeled. So I found that on Kaggle, and I had some friends that also wanted to try this. So like on weekends, we were like having mini hackathons at my place. It was really fun. Third thing is that I was looking for a job, but I wasn't sure what would be the right fit for me. So ultimately, I created my job. And that was a matter of finding a good mentor. So I looked around, and I found Sylvie Raté, who's actually a professor here at the ETS. She's an expert in natural language processing. She has her PhD from MIT, and she's been a professor here for like, I think 10 years or so. And she's also in a lab where other professors are experts at machine learning. So I thought, well, this would be a great environment to learn that part, like that skill that I really want to get. And I wanted to also work with an industry. So I found a company called Science Metrics who had like very interesting, a very interesting data problem to solve, which was to like figure out like, if I, so they have like millions of scientific papers, and they need to know how they are classified, so they can do analysis to say to the government, like, oh, since you put that amount of like millions of dollars into nanotechnology, like these are the papers, like there were like more papers in nanotechnology that were published that year, that sort of thing. But to do that, you need to know how many papers were published in nanotechnology, and it's not necessarily easy. So I thought that this was like the perfect project for me, because I'm a scientist, I want to do machine learning, and let's sit all together at a table and figure out like a cool project we could do together. And I got some financing from MyTax. MyTax is an organism that finance like postdoc. So this project was a 1-year postdoc with them. And also MyTax gives money for internship for grad students. So if you're looking to be like halfway in academia, halfway in an industry, that's a good, well, that's the way that I did it. Yeah. And that year was great for my own growth. I learned a lot. I learned what I like, I learned what I don't like. And then I got hired at Shopify, which is where I'm working right now. And it's very different, because now I'm not in physics anymore. I'm actually at a company that sells, actually, yeah, maybe you don't know Shopify. So Shopify is mostly known for its e-commerce platform, but they also have like point of sale systems, and they're behind like the buyable pins with Pinterest and the stores on Facebook. So if you want to sell something online, that's what Shopify helps people do. So I'm thinking a lot about how e-commerce works. And customer goes in, and then you make profits. And I spent a lot of time working out those 3 little question marks there. And if I can sum up the work that I'm doing right now, I'm solving a relevant problem that helps people, because most of our merchants are actually entrepreneurs. They're like mom and pops that want to when they're retired, they want to live their dream and have their llama farm, or no, their alpaca farm, and like sell alpaca yarn on the internet. Or they want, but for real, like there are so many people that have so many dreams, and that helping them achieve that and helping them be more successful by using data to help them get their next sale is something that brings me a lot of joy in the work that I'm doing right now. And I'm also doing it using cutting-edge technology. So we have this huge Hadoop cluster with Spark on it, and our amazing team of data engineers are actively contributing to Spark, because it's still developing and it's not perfect, and we run into like all the bugs and edge cases, but that's what makes it also exciting and makes you feel like a pioneer in the field. And so if you've been paying attention, the 2 last slides were the same for my PhD. So basically what has changed is the domain knowledge, but the underlying motivation is always the same kind of thought process that I applied in physics. I apply it with e-commerce. And yeah, so if you're in a position right now to hire for your team in a tech company, and you're looking for people that have a background like that, have studied in like software engineering or that sort of thing, I would challenge you to try to cast a wider net, and also consider physicists and chemists and biologists and neurobiologists and all of those great scientists out there that went into a field because they were curious, because they were passionate. And I think that if you have someone that's curious and passionate on your team, that could also help the diversity of your team. And well, I would say that my teammates are like happy to have me, even if I'm not like an engineer. So, so yeah. How to measure your e-commerce business? So first of all, how many of you here, by show of hand, how many of you are selling things online? Nice. A few people. That's cool. So if you have researched like how to measure like data analytics for e-commerce or that sort of stuff, or even for businesses in general, you probably have encountered KPIs. KPIs are a key performance indicator. Thank you. Key performance indicators, and like you can search for that, and like you will have like countless blog articles about like the essential 35 key performance indicators for your business. And I would argue that if you need 35 key performance indicator, they're not really key performance indicator. You should really like have a handful that really works for you. And these are your key performance indicators. The other ones are still performance indicators, but those are not the ones you should know on top of your head. And this is the kind of thing that, that kind of data analytics, like you would have that on a dashboard and look at it on a daily basis, or like have a daily email in your inbox that tells you like, these are the numbers, these are how they changed since yesterday, so that you know if you should press like the red button for the alert and like do something about it, or if everything is well. So there's already a lot that has been said about KPIs. One of the great talks that I've heard about it recently was at CrunchConf. Someone from SurveyMonkey gave a great talk about it. So I have the link at the end of my talk. So I would encourage you to learn more in that way, because I don't want to spend a lot of time on KPIs today. Another thing that you probably have heard a lot about is A/B testing. A/B testing is all the rage. A/B testing is basically like if you have a website and you wonder, or even other products, really, but it's usually in the context of websites, and you wonder, like, for instance, would this layout work better for converting, meaning would people buy more if they see a layout like this, or if they see a layout like this, or like if I change the color of the button, or if I change the call to action, or like the copy of the page, or that sort of stuff. So like you can make this hypothesis that one would convert better than the other, take your traffic, split it in two, measure, and then at the end say, yes, this one is better, or no, both are. No, it's inconclusive. There are tools to do that out there, and there's a lot of people that have talked about A/B testing a lot. I also have, so there was Andrea Burbank from Pinterest that talked about that at the same conference that I will give you the link to at the end. So I wanted to just to give you an overview, to tell you that these things exist, because like they take a lot of space when we talk about metrics and e-commerce. But what is rarely talked about, or like I haven't really had a good sense for it, like when researching for this talk, like nobody really talks about exploratory data analysis in the context of e-commerce. Or maybe they do, it's just that I don't really know them. So that's what I want to talk a little bit more today. And if we go back to the scientific method and we, just like take out the colors a little bit just to make it more readable. So how can we apply the scientific method to how we measure the performance of your e-commerce business? So, and how does that link with KPIs and A/B testing and exploratory data analysis? So basically, your observation is, this KPI is low. So let's say a very common KPI for e-commerce is conversion rate. The conversion rate is out of those many people who came to my website, it's a fraction of people who actually bought something. But also conversion rate can mean other things like out of the people who saw this page, those are the ones who signed up for my newsletter. So conversion rate is that fraction of like people who saw something versus those who actually did the action that you wanted them to do. And then your question would be, how can I improve my conversion rate? And then the hypothesis and prediction stage would be, okay, well, I hypothesize that this should have an effect, and this effect will be that. But all the secret sauce happens there, right? Like, how do you figure out which is the thing you should try? Like, what's the next thing you should try? So that's all part of like these exploratory data analysis phase. And then once you know what you want to try, then you do the A/B test, which is really the experiment part of this whole framework. And then you can say if yes or no, you move the needle on your KPI. And then like no, you start, yes, yay, celebrate, and start the cycle again. So yeah, like figuring out the X and Y in this is not evident, and it's something that you can, you can brainstorm with your colleagues. You know your business, you know your users. Like if you have already a brick and mortar shop and you're trying to sell stuff to people, like you know who comes into your store. Like you know, are they young? Are they old? Are they from around here? Like how do they talk? How do they like should I like how can I pitch to those people? Like you want to know a little bit more about the people. Like are they? Yeah, so that's what you would do, like if you would see people in real life, but on the internet, it's like you have it in your log, like, oh, this was their IP address, and that many people came from here, or like this is the page that they saw just before, or like, oh, they all came from Facebook, or oh, they all came from my Google AdWord ad. So those are the kind of data that you have and that you can start brainstorming with. So I want to share with you some ideas of, where can you start when exploring your data. One of the important things is that like you say, okay, I have like 5 hours today to devote to this thing. Where should I put my energy, right? Don't spend time trying to optimize something that doesn't need to be optimized, or that if you optimize it, there's no traffic on that page, so it won't really make a difference. So a first good question is like, which are the pages on my website that have high traffic and high bounce rate? Bounce rate being the rate of people who leave that page and don't continue on your website, or like don't buy something. Because that's where your efforts will pay the most. So with the data that you already have, you can figure out those kind of things. Another thing that is really a gold mine is the search terms of the search terms that people are using to find your website, and once they're on your website, what are they searching for? And I have a very nice anecdote with this, because like the first thing I did at Shopify when I started to do merchant-facing data stuff was actually surfacing to them, hey, these are the 5 most common search words, search terms on your website. And actually the day after, a merchant called us to thank us, because she was selling those very fancy flat shoes that you can have in in your purse when you go like to a wedding or to a party and like you're wearing heels that are uncomfortable, and like at the end of the party you take out your heels and you put on those like fancy flat shoes that are really comfortable. And people were searching for wedding on her website, but she said like this has nothing to do with weddings, but maybe like someone wants to have, you know, a bulk purchase for, you know, their bridesmaid or something. So she just like 5 minutes, like she just made a page for, oh, and we have like special discounts for weddings, like bulk orders for your bridesmaid, and like she made $1,000 of worth of sales with that page just the day after. So looking at what people are searching for, you can really have an insight about like, oh, like people have this need, and I can really address that need with my product. You make people happy, and you are happy because they're selling, so that's great, win-win. You can track also funnels. So for instance, if you want to give a discount code to all the people who are on your email list, you could, the funnel would be like how many people receive your email, how many people opened the email, how many people clicked on a link, how many people went to your website, how many people added something to their cart and ultimately bought it. So by knowing like how many people are at every stages, you can find out like where's the bottleneck, where's the problem in there, and try to address that and put your effort into that first. And also segmenting can be very insightful. So for instance, on my web store, I have products and I also have a blog, and maybe the people who are interested in my blog are not necessarily interested in the products in the same way, or like they don't behave in the same way. So I could segment my users by, did they first went to my blog page, or do they first went to my products page? That sort of thing. So that would be segmenting by content type. Also, if someone sells, say, clothing and jewelry, then maybe the two types of products are not performing in the same way. So that's also something to think about. Or by referrer, the people who came from my Facebook fan page, do they behave in the same way as the people who come from organic search? So that's another thing to think about. But I put something there, beware of false positives. So have you done some statistics in university or like CEGEP a little bit? Okay, that's great. You are mathematically literate, which is great. Because sometimes I hear things like, oh yeah, when you do an A/B test or like when you segment, like you have to segment in about like 15 to like 20 different ways before you find a significant result. And if you're using a p-value of 0.5, that means that if you're segmenting noise in 20 different ways, you're like almost sure to find one false positive in there. So just always be mindful of when you're playing around with data and you say that, oh, okay, this has a small p-value. It must be the truth. P-values are just a tool to like help you find those gems, but that doesn't mean that like you should base all your product decisions on like one p-value, right? Actually, it's the third time that I refer to CrunchConf. There was another talk there. You should really watch all of them if you like data. I love data, so I went there. It was great. Someone gave a talk title like how to segment data to show false positives to your boss. It was very insightful. Use your statistical math knowledge. What's my process when I do that kind of thing? So first I get the data, and then I explore it, and then I scale. And what do I mean by scaling is that my job at Shopify is to provide data insights to 250,000 merchants. So of course I can analyze my own data about my own shop on my computer and dive deep into that. But then how do I offer the same to like 250,000 people. Spoiler alert, I use big data architecture. So first thing, let's get all the data. So you probably have data scattered a little bit everywhere. One of the obvious things that you probably do, and if you're not, you probably should be doing, is using Google Analytics for tracking analytics of your e-commerce venture. You can use the API to get the data, or export as CSV files. The API, like I could have done just a whole talk to like, a whole workshop on using the Google Analytics API. I have a resource at the end of my talk to help you do that. Maybe you have your own database that you can connect with. If you're using Python, SQL Alchemy is a good library to help you write SQL queries, get your data, and then you can like join it with all the other data sources that you have in your Python notebook. My shop is on Shopify, so I can use the API or export my data as CSV files and read it in Python. Maybe I have personal spreadsheet, maybe I have data a little bit everywhere, but the thing is that you can identify as a first step, like where does your data live, and then bring it all together at one place, because I feel that a lot of insight comes from blending all those different data sources together. And the tool that I'm using is called Jupyter. That's for Julia, Python, and R. Maybe it's Jupyter. Jupyter. It was previously IPython notebook. And why I really love this tool is because, well, I'm a scientist, so like I'm used to like taking notes about everything and like keeping trace of everything. And this is a notebook where you can write notes, you can write equations in there with the markdown. You can write code and execute it directly in the notebook, and you can print out the result. So if your result is a graph, then you already have like everything that you need to know, like all the context, like why you're using this, that's written in Word, then you have your code, and then you have the result all in one place, which like makes it super easy to understand when you come back to it later. And you can like jump between the different cells and like execute each cell separately. Actually, I can show you. I have a notebook, and yeah, it looks like this. It's on my GitHub. I'll give you the link at the end, but I just wanted to show you, like, the rest of the presentation is basically going through that notebook. So let's explore. So as I said, I'm selling things on the internet. I'm selling T-shirts. And what kind of T-shirt? Well, I'm a physicist, and I have an excellent sense of humor. And a fine sense of design. So I design beautiful T-shirt that I sell for. Basically, my clients are other like grad physics students, because yeah, it's a very niche. Like, to understand the kind of jokes that are on there, it's pretty niche. And one of the things that I've learned about selling things is that if you give too many choices to a customer, like, customers want to have choices, but like if you give too many choices, they freeze, and like they don't know what to choose, and then they leave without buying anything, because it's like paralysis by too many choices. So the experiment that I did, I just like printed my designs on like all the colors possible and let people just choose which color they want. And that's been going on for like months. So now I can analyze the data and see like what are the most popular colors for physicists, for T-shirts, and focus my next design on this color. So what I will do, I would look at my past orders extract the colors, and find the most popular. And I realized that like in all the talks that I saw today, I never seen a line of code, and like there's some code coming on. So, so by show of hand, how many people here code for like a living or like in their life? Cool. Thank you. Like I thought I would like lose everybody, but at the same time, yeah. Okay, I won't make it too technical, but there's some code involved. So yeah, I told you I'm using Python and IPython notebook, and one of the great Python libraries for data analysis is called Pandas. Pandas was introduced to me by probably you all know Julia Evans, because she's so wonderful and well-known in the Python world. And she introduced it to me by saying, hey, at work, when people cannot load a CSV file in Excel because it's too big, I use Pandas. Or when they can't load a CSV file in Excel because like there are like null values and like weird stuff everywhere, I use Pandas. So Pandas is very good at handling all those weird things where there's values missing and like different data types together. It's pretty powerful, and it makes it like really easy to slice and dice data and like visualize it very fast. So I think in 5 lines of code, I will find my answer. So so in Python, you always start by importing. So we import pandas, and we want to read a CSV. So there's a very handy function called read CSV. And now my variable orders is a data frame, and a data frame looks like basically a table. It's got rows, it's got columns, and there's information in the cells. And just to make things clear, like I made some data up to like preserve the privacy of my customers. So no, Stanley Kubrick is not one of my customers. So I can do like dot column to know what are the columns in my orders table, and there are lots of them. So like if you look at actually like the table, there's name, email, financial status, and all of these things that are here. And actually there's only one column that I want to know. It's my line item name. And my line item name is like the name of my products plus my variance. And this is a little bit complicated because yeah, there's the name of my product, and then there's a dash, and then there are my variants. But sometimes the color is there, sometimes there are no colors, because sometimes I do special requests, or like my baby onesie that has P is for momentum on it. It's like super cute. It's only offered in yellow, so I don't have the color yellow in there. So yeah, so like, how do I extract those things? This seems like very messy. So I will go about it in two steps. The first step will be, let's get all the variants, and then from the variants, let's extract all the colors. So I just write a first function to extract the variants. Basically, it gets the line items, and then it gives me back the variants. So I'm using the function map here, and it's kind of important because later when I show you Spark, I will be using maps again. But basically what it does, map will take like every, let's say, every value of orders and map them to the function getVariance, and then give back each variant. So you see the result here. I get a list of my variants. Sometimes it's a model, men or women. You can see that my customers are mostly men. Yeah, a couple of women in there. The size and also the color. And then to get the color, I have a lot of colors, so like I could have just made a list to like list all my colors, but it's easier to just list the size and models and say if variant is not in size and models, then it's a color. That's one of the things that I really like about Python, is that like even if you don't know Python, you can read this and it reads as, you know, it looks a lot like English and makes it like easy at least understand, or like when you communicate with your colleagues about like, oh, like this is what I did for my for this data analysis. Like even if they're not Python expert, they can like read, and it reads like English, so I like it. And I'm using also map again, and I can just chain another step. Like so, it's the same thing as before, but now I just add map, get colors. I get the variant, I get the color, and these are my results. So when there's something, I get the color. When there's nothing, I get the none. And let's just count them. There's a nice function called value count. So here I have already my top two or my top three. But if I really want to get fancy, I just can, add dot plot at the end, and it gives me a graph, which is very, very powerful because I was used before, like to, I use MATLAB a lot, or I use Matplotlib with Python, where like you have to define what's the title, blah blah blah. With just you just say kind bar, and the plot is, it's not perfect. I would not like use it directly in a scientific paper, but like just the very bare bone defaults of those graphs like makes them really nice and easy to do. So that when you're just like slicing, dicing data, trying to gain insights very quickly, this gets the job done. And you see that's 1, 2, 3, 4. It's actually one line of code, this thing. I could have put it all in one line, just chaining functions together. And this is my answer. So if you didn't know like what eggplant and seafoam looks like, it's like a pale green and a dark purple. Yeah. I was about to like explain those, but it's you can ask me in the questions if it's really important to you. So yeah, I look at like how I could do this with a spreadsheet editor, and I'm by no means an Excel ninja. Some people might be able to do it, but like the color is not necessarily always in the middle, is not always necessarily present, so I'm not sure like how easily you could have done this with a spreadsheet editor. So yeah, so if you're not already programming, this might be a motivation for you to do it. Then I want to talk about another big question, which is there a problem with my shipping rates? And by a show of hands, how many of you have been on a e-commerce website, put something in your cart, and go to the checkout, enter your address to see what's the shipping rate, and just abandon your cart right there, right? Right? So when you are selling things online, like shipping rates is a big deal. Like, should you offer free shipping? Should you offer free shipping over a certain amount? It's not easy to figure those things out, and there's a little bit of maths involved in there. There's a little bit of hunch. You need to know like is there a problem with your shipping rates in the first place? And I was having lunch at my office with a merchant that's in Montreal. She's selling beauty products for black women for curly hair. I haven't bought anything from her yet, but I should probably. But yeah, and she's and she asked me like, how do I know if I should offer free shipping? Because like she had this hunch that there might be a problem because she's like she's very active with her business, and it seems that like, the sales were not like going up anymore. So we sat down together, and I looked at her data, and was wondering like how can we figure that out? And she has a Shopify store that uses a checkout that has these steps in it. So like if you're on a website of those steps, then you could use also the same strategy. So first step is you go to the contact info page, and then you enter your info. And then the next step would be you go to the shipping page, and then you enter your shipping address, and then you get what would be the shipping rate. And then you go to the checkout, and you actually, well, you're already in the checkout, but you go to the payment page, and you actually enter your own, your credit card. And then the last thing is the thank you page, where you actually buy something. And of course, for a merchant, the idea is to have as many people who go from the contact info to the thank you page. And so if you know how many people reach the shipping page but never reach the payment page, that gives you a drop-off rate that could be a very good proxy to know like how many people are actually like going to that page to see what the shipping rate is and then just abandon their cart. So if you're using Google Analytics, it's pretty easy to do, but you have to set up the funnel yourself. So again, a funnel is like this series of steps that a user goes through, and in this context, we're talking about the checkout funnel that goes from the contact information to the thank you page. And yeah, so like you can just go there and get that number. 37% that continues from the shipping info to the payment info means that like there are 63% people who drop off, which is a lot. In my experience, it's more like around 12% that drop off between the shipping info and the payment info. So if you have like 40% and up, you should probably look into doing something about it. Now, if you really want to do the same thing with Python, this is what the CSV from Google Analytics looks like. It's really messy because it doesn't have the same, it's like many tables in one file, and at this point, Pandas doesn't, you can use Pandas for it, but it's kind of weird. It doesn't work very well, so I just like wrote something like with try and accept. Anyway, you don't need to know this, but it's basically like you can get the same number by like figuring out like how many people didn't go to the next step, and figuring this out as a percentage. And yeah, so with that that merchant, we figured that this number was really high for her. Then the next thing that we figured was what would be the, that, like if she wants to offer free shipping, she cannot just offer free shipping on everything because she doesn't have the margin to do it, but she can offer free shipping over like $45 or over like a certain amount. And how did we narrow down on $45 is that we looked at the people who abandon their cart. What is the value of the items in their cart? And like if you add up like, okay, like 2 bottles of shampoo and a special comb for your hair is like about $40, $45. Well, if we offer free shipping over $45, then it would make sense for those people to buy it right there, right then, because they would have free shipping. Or to say, okay, well, if it's $45 and we offer free shipping over $50, then maybe it will motivate them to add something more in their cart and check out. And yeah, I should have put that on my slides, but I actually have a blog post on the e-commerce university blog of Shopify that shows that she did that, and we measure like before and after, and she doubled her revenue with this. Of course, she paid more money for the shipping, but hey, double revenue, that's great. And yeah, and like more explorations, ideas. Are the people that are abandoning their cart, are they from a certain country? Do you even offer shipping there? Maybe you should. Maybe it doesn't make sense for your business, but it's the kind of thing that it's data that you already have and that you can explore. And then I want to talk about scale. Is this the 45-minute thing, or? I have 10 more minutes total. Okay, so anyway, I will go fast on this and then questions. So this is actually one of the things that I do. And yeah, so I'm responsible for my team is responsible for a product that is called Insight Cards. So it's insights that are powered by merchants' data. And this is the result of helping one merchant to figure out if she had a problem with shipping rates. I can scale that and just do it for everyone using our platform because I had that snippet of code, of Python code, that I can do it for one person. I can just take the data of everyone and do it for everyone, which is pretty great. And then I work with nice front-end developers that can put it in a nice format like this. And yeah, how does that work? Well, so far, what we've done is that, with data analysis or with computers in general, you have an input, you have some crunching, and you have an output. So the input in this case was a CSV file that we've put into a Jupyter notebook, and the result was printed on a page. But if we want to scale that, I cannot just use my laptop. I need to have a cluster of computers. I need to parallelize the code. And how can we do that? The way that we've done it at Shopify is with Spark. Spark is a framework for cluster computing, meaning that I can use many computers to run the code in parallel, and it will be much faster than using my poor little laptop. And then same thing with the data. I cannot just have one CSV file on my computer. I need to have that data replicated across many machines in the cluster. So for that, we use the Hadoop distributed file system, which was something that I figured out during my transition year, that even if you have a terabyte of memory on your own computer, it makes sense to have that data replicated a little bit everywhere, because there's always a chance that when you're copying data that there will be a little error, and that will crash everything that you do if you only have one copy of that data. So having the Hadoop ecosystem already takes care of all of those little problems. So it replicates your data across the cluster. So if there's a machine that crashes, your data continue to live somewhere else, and it's very resilient, and it will continue to work. And Spark is written in Scala, but we use PySpark, which is the Python API, to Spark. So with the same code that I've shown you earlier, I can just make very little changes, and it can get parallelized and crunch the terabytes of data that we have. The key differences with what I've done earlier is that earlier I was looking at just the data for one shop. So one way to do it for all the shops is to, each record will have a key for the shop, and then we can do all the crunching on all the data for one shop, because we don't want to start, adding everybody's data together and mixing things up. So keying by shop ID, and then we want to use filters because, I don't want to give you a bad data insights. Like I said to you earlier, we have to be careful when we segment data to make sure that it is statistically significant. The same thing applies here. If you have only 3 visitors per day, it's hard for me to give you significant statistics on it. So I use good filters to make sure that we have enough data to represent results, and I give advice based on data that is statistically significant. So this is an actual snippet of production code. It's very similar to what we had before. Like I said, you have, before we had a data frame. Here it's called an RDD, and a resilient, darn. It's always when I'm on stage that I have those blanks, sorry. But yeah, an RDD, and then you key by shop ID, then you do your adding things together, then you filter when you don't have enough data for a shop, and that's pretty much it. How simple was that? If you were mystified by big data, and I'm writing code parallelize, Spark and Hadoop and stuff, this is it. It's it's not that hard. So yeah. So yeah, I want to, I hope I've conveyed to you the need to be curious and explore your own data and ask questions and find those opportunities and cast a wider net, hire a physicist for your company. I know there are some physicists in the rooms that are looking for jobs, not me, but like other people. So yeah, hire them. Cool. Thank you.
Thank you, Françoise. We have time for 2 questions. Someone has a question for her? No question yet? Oh, coming up there.
Hi, I really enjoyed your talk, so thanks for that. My question is and I know that I've bought things on Shopify stores before, and I'm sure I've bought things on the web and not known that I was using a Shopify store. I'm just curious as to what you think about the possibility in the future to kind of, for Shopify to do a sort of like meta-analysis of all of the analysis you talked about today, to start giving merchants like prescriptive kind of tips about like, you know, maybe your conversion rate at this point is not as strong as it could be because X, Y, Z, to sort of start giving people, because it sounds like the data that you must have could give merchants additional insights into like steps they could take to correct whatever might be going wrong on their site.
Yeah, exactly. We have so much data. I think we started with you know, we always want to build from the ground up. We started with the easy things, with the things that were most evident or that were the most easy to do, and we're definitely going towards that direction. And also we started using network data, so like to be able to tell you shops like you are having success this week by doing this thing. Maybe you could do the same or not because like you're different and you have another business strategy. But yeah, that's definitely something I want to do in the future, to try to figure out like what event, like, oh, your conversion rate is down. Is it because like you have suddenly more visitors that are not necessarily buying more, or is it just because you have the same amount of visitors but they're not buying? And it's all very complex questions to answer, but that's definitely the kind of direction I want to go.
Another question? No, so there's another break, and there's cookies served outside, and it starts again at 3:45. Thank you. Thank you.